Hello everyone. In this club, we are reviewing this PR. So let's see. So the PR number is 31340, and this PR basically it's just a test and nothing else. But the concept under the test in which the test implemented on is very good concepts. More than the code changes in this PR, we are focusing more on the concepts under which the test case is implemented. Okay, so the title of the PR, it's nothing like it's add a missing SegWit version 1 test case to script standard test. So script standard test is just it's just a test case written in C++ and it's a unit test case. So all the tests written in script standard test are checking the standardness of the many scripts like pay to public key hash and pay to witness public key hash and pay to sh and many more and pay to taproot also. It's just checking the standardness of the script. Will look like what we call standardness regarding a script. So like we have two SegWit output scripts right now. First one is version 1 Taproot. Uh, in short form, we call it as P2TR, and other one is quite new, which is P2A. The abbreviation is like PayToAnchor, and this is the new thing implemented in Bitcoin Core. Maybe you don't know about much PayToAnchor scripts. So this script is basically implemented on transaction version 3 relay. We'll see what is transaction version 3 relay. So let's see what is PayToAnchor. So this is the main PR of PayToAnchor scripts. Basically, this is not the standalone PR for this PayToAnchor. So the idea of PayToAnchor implemented layer by layer. So let's go one more in depth. So I'll okay. So let's see what is ephemeral does and what is the version 3 transaction relay and all of this. So let's first start looking at the simplest definition we can find on Bitcoin Optech, which is transaction v3 relay. Okay, so this is the standard definition by Bitcoin Optech. So what it say? The version 3 transaction relay is a proposal to allow transaction to opt in to a modified set of transactions relay policies designed to prevent pinning attack. Okay, what is pinning attacks? We'll get into it. So it's combined with package relay, and these policies help to enable like dynamic fee rates and all. And it's also used in the LN network, Lightning Network. So how does it all the things work? We'll see. So first there is a problem called transaction pinning. So what is the transaction pinning problem? So in this there are two rules in BIP 1 to 125, the two RBF rules. So using these two rules, an attacker can pin the transaction in such a way so you can't uh, you can't process the transaction in the blockchain. How it's done? Let's wait. For example, BIP 125 RBF rule says requires a replacement transaction pay a higher absolute fee than the sum of fees paid by the transaction being replaced and all of its children. Do you, as most of you are know like what is RBF, what RBF can do. For example, if you broadcast your transaction into the blockchain or into the mempool, not blockchain, into the mempool, and if you pay a very low fee, for example, you pay a very low fee, like lower than the average lower fee rate, then your transaction may get stuck because no miner will pick your transaction because you are paying so low fees and nobody is interested in mining your transaction and all. So to prevent this situation, there is a concept in Bitcoin called RBF, in which what we do, we just create another transaction and pay with the same input as we pay in the previous transaction, but in this new transaction, we increase the fees. We just not increase the fees by zero point 0.1 or 0.2% of the previous transaction, but a higher fees, like not just written here. It's a higher absolute fee, not just the fee rate. So we are increasing the whole fees. So let's see further. This can allow an attacker to attack a large and low fee rate transaction to the transaction they want to pin, forcing any fee bump to pay for the replacement of the large style transactions. So, like example is in 2019, a Bitcoin Core default, an attacker can require an honest participants pay a minimum of 0.0001 fees to bump a transaction or in a greater amount. So, in this case, example, there is an attacker, like you are two persons with a pay to MS account, like pay to multiple script, like you both the person uh, can create a RBF transaction. So what does it do? Like, and in both of you and your partner, suppose your partner is attacker with a bad intention, so they just create a first parent transaction with very low fees. For example, let me let me open a whiteboard to understand you better. So suppose uh, suppose this is the parent transaction. I hope you understand what is written here. With a fee of suppose 0.000 and 0.01. Okay, suppose this is the parent transaction. Someone created this transaction with a very low fees. So in this phase, no one interested to mine this transaction. Now, what an attacker can do, suppose he will create another child transaction like this. This is the child transaction. I represent it with C. Now, what we'll do here is this will increase the fees by just a little bit like this, 0.2. Now, this child transaction is not possible to mine also because it consists of very low fees. And attacker do this practice like as many times like the required limit reached. For example, he creates another child transaction with just a increment of a very low fee, and the process goes on, and there is a limit set by Bitcoin Core here. This is the limit. When you hit this limit, what happens, like you can't create more child transactions here. For example, here you can't create any transaction because this is the maximum limit you can create the transaction for a single parent. This is the maximum limit. You can't create further this line. So if an honest user try to create a child transaction above this line, they won't do that, or they can't do this because an attacker already overflowed the child transactions with so many lower fees. So this is one kind of pinning attack. Okay, yeah, that's the point number two, in which this rule designed to prevent many other attacks, but this rules also create this type of attack. For example, maximum package size limitations prevent CPFP from being used if a transaction has more than 101,000 virtual bytes of children or descendant in a mempool, or has more than 25 descendants or ancestors. Okay, so this can allow an attacker to completely block fee bumping by creating the maximum amount of child transactions. That's actually what I shown. An attacker just simply blocks the further limit of creating the child transactions because it already created so many transactions with very low fees. So you can't create more transaction. So these two things are called transaction pinning attacks. This is transaction pinning attacks. I think you understand this very well. What is transaction pinning attacks? Let's get back and see what is how we can use version 3 transaction relay to prevent from all of these attacks and all. There is one more concept of package RBF. So let's see what is a package first. So we'll see what is a package in terms of Bitcoin terminology. What is a package? So in Bitcoin, suppose there is a set. Suppose this is a set which consists of 4 transactions. Okay. Oh, sorry. Okay. This is a set which contains 4 transactions named A, B, C, and D. These A, B, C, D are whole transactions, you can say. Now, for example, if A spends B uh, and B and C spends D. What spend like C contains the output, the input amount as a D output, and A contains the input amount of B. Then this whole package, what we call as a transaction, and somehow B and C is also interrelated to each other. Okay. For for another example, a small example is if there is only 2 transactions, and if first transaction is related to the second transaction, then this will create a package. If there is a 2 transaction also, for example, there is A, B, and C, and if A spends both B and C, like transaction A spends the input of these 2 transactions, B and C, then this is also called a package. So a package simply means interconnection between any n number of transactions. Okay, so so okay, transaction replacement. Let's see what is ephemeral anchors. Subs so first is ephemeral anchors and ephemeral dust. Okay, so the first policy, yeah, there is another thing called anchor outputs. First, to understand what is anchor outputs. So, so to prevent the transaction pinnings and all, we designed this approach called anchor outputs. Then anchor outputs are special outputs in LN commitment transactions that are designed to allow the transaction to be fee bumped. What is fee bumped? You all know, like creating a child transaction with a higher fee is called fee bumping a transaction. An earlier name for this proposal was simplified commitments. So each time the balance changes in an LN channel, a commitment transaction is created and signed by the participating parties. The transaction is only broadcast if one party decides to like close the channel, and so and there is also like paying a too low fee rate may prevent the commitment transaction from confirming before any time lock contained. This is the same thing I like shown earlier via whiteboard. Like if you pay a very low fee, your transaction never be in the blockchain, be mined. So this will allow the funds to be stolen or expire or stuck, what you call. So the solution to this is for the commitment transaction to pay a minimal amount of fees and then to allow either channel participate to fee bump the transaction. So it's like suppose there are two-person, one and two. Let's call these are two actual owners who needs to like who needs to communicate with each other. Uh, what me what we mean to communicate means they want to make a transaction with each other. Okay, so what we do in anchor outputs, we create a transaction. For example, suppose this is the transaction. Okay, and what we do, we create a we create in the output. This is the output, and this is the input of the transaction. So all the fields are like same for any transaction like input, amount, transaction ID, and reference to the previous transaction IDs and all. These are the same for any transaction. These one is also same like where you want to send your money and all. This thing is also same like any other transaction. But the change thing is here is we are introducing a new type of output here, and we call this output called anchor outputs. Like, sorry for the bad handwriting. Then I think you will understand. Like, this is anchor outputs. Uh, I don't know where is eraser. Yeah, okay. We don't. Okay, wait. Yeah, no, not this one. Where is my pen? No, what happened to my pen? Okay, sorry. So, suppose this is anchor output. So what this output contains? This output contains a very low amount of satoshis. For example, zero. Sorry. For example, 0.00 and 0.00 and 0 and 1. These amount of satoshis this anchor output will contain. But the thing is anyone can spend this output, like anyone can spend this output. You don't need anyone means like anyone in both of these person can spend this output. There is no restriction like who can pay, anyone can pay, whether it's a person one or it's a person two, it doesn't matter, anyone can pay this out. So the improvement here is by spending this output, any one of these two can fee bump a transaction. For example, if uh, if first person wants to wants to like pay their output as an input in this transaction. Suppose uh, what happened to my wait. Wait a minute, I will fix my mouse. Okay, now suppose if this is the first person, they needs to spend their output as received here as an input. But what he will do? They will also spend this anchor output here. They just list this anchor output as an input here with their original output, and he pay like very huge fee like 0.02 BTC for a fee. Let's say he paid this as a fee. Sorry, as a fee. Like, like you know what I'm saying. I'm trying to say. This is fee. Okay. Never mind. This is fee. So due to this very huge amount of fee, both of this transaction will enter in a blockchain and both will confirm in a block because this transaction pay a higher fee, and this is a fee bump transaction because this spends the output of this transactions as an input with a higher fee, and any one of these owners can pay the fees. Uh, so this child transaction can fee bump this parent transaction also. So that's the benefit of anchor output. That's the benefit of anchor output here. So anchor output is nothing but small outputs which with a very small amount of satoshis in there. So any one party can pay spends these outputs as an input in their transaction, and through this process, the child and parent both transactions successfully entered in a like confirmed blockchain. So, but there is a limitation. Why we need to implement the ephemeral anchors when we already have anchor outputs? Because anchor outputs only require at most two people to transact with each other. Like if you are three or four or more than four people, you don't like really pay with anchor outputs because it's only allow two parties involvement to create a transactions, not more than two. That's why ephemeral anchors are introduced. So what ephemeral anchors do? They are very similar to this anchor outputs, but the thing is, in ephemeral anchors, suppose this is a transaction same, all the things are same as any transaction, but in a ephemeral anchors, suppose we create a anchor here called ephemeral anchor. What this anchor is do? So this anchor, like, we don't require any like Satoshi or any fee to create this anchor. It's a simple output with a zero value. Like this contains 0.0 Bitcoin in it. Whether in an anchor output, you need some amount of Bitcoin to be spent. Like in ephemeral anchor, we assign this with a very low amount of Bitcoin, like 0.0000 and 1. But you can create an ephemeral anchor with no value in it. That's the first advantage of ephemeral anchors. And the second advantage is like no matter how many people can participate in a transaction while creating, processing, or signing it, any n number of people can use this feature. There is no restrictions, and we'll see how we can avoid the pinning attacks here. And that's the updated policies introduced in Bitcoin Core as a version 3 transactions relay protocols. I will show you. So You understand what is ephemeral anchors? It's nothing but a output with zero value, a zero value output. So how we can benefit from this output? Okay, suppose like there is another transaction. Suppose this transaction contains 10. Suppose this transaction contains 100 inputs and 50 outputs. Okay, 100 inputs and 50 outputs. Now, suppose anyone anyone of the receiving outputs here needs to like spend their funds. But suppose this transaction isn't in blockchain, isn't in mempool right now, because of the many reasons, like maybe this transaction aren't paying enough fee to get processed by the miners, or whatever the reason. Suppose this it's still in the mempool. This transaction is in the mempool right now. So, and someone needs to spend their funds. So how he or she can do it? So what he do? They they spend their they create a transaction with their desired output as an input, but they also spend this ephemeral anchors here with a zero, because anyone can spend this ephemeral anchors. There is no condition. That's like pay to anyone script. Ephemeral anchors is like pay to anyone script. So anyone can pay this, or so this is the transaction he created, and he pay a higher fee. For example, this pay zero point 0.3 as a fee. This is the fee. Okay, this is the fee. Now, because of this high fee, what will happen? This parent transaction also processed by the miners, and this also clears the mempool, and this also processed and get verified in the blockchain. Why? Because this transaction pays a higher fee, and this spends the same input return like here as output. And one more thing, suppose there is another person. Suppose there is a person whose input or output doesn't listed here in this transaction set. Suppose there is a third person, and he want to process all these transactions. What he can do? He just need to spend this ephemeral anchors in their output. Suppose there is an unknown person. We don't know who is, and who is this, and he just spent this ephemeral anchor here and pay a very high fee, like 0.1 BTC. That's not the actual fee. I just try to explain you here. Suppose a third random person can also spend this. Is anyone trying to speak? Okay. This third person can also fee bump this transaction. That's the second advantage of ephemeral anchors. So if you include ephemeral anchors, anyone can fee bump the transaction, whether it's the owner of these outputs or not. Anyone can fee bump the transaction just by spending this ephemeral anchor. Ephemeral anchor, it's just output as a anchor output. They both are same, but anchor output contain some small amount of satoshi, but ephemeral anchor doesn't contain any amount of satoshi. It's just zero or null value, but we can spend, and anyone can spend this ephemeral anchors. Okay, sorry. So there are some uh, there are some policies I can show you. Wait, let me find where does it goes. Yeah, I think this is, yes, yes, this is. So The transaction version 3 relay proposed in this bit, like BIP 431, and the concept is topological restriction for pinning. The title for this PR is this. So this PR introduced, it's like that's the motivation of the PR. Like mempool typically accepts and relay transactions that spend same outputs from other unconfirmed transactions, but restrict package size through ancestor and descendant limits to limit the computational complexity of mempool operations and mitigate denial of service attack. For example, you can't create any number of child transactions, something. So it restricts you. The previous policies restrict you from creating the more descendant transactions. So it introduced, yeah, these are the two rules I just talked about, like RBF pinning through absolute pay. Because of these two rules, the attacker can exploit these rules uh, to to restrict anyone to proceed further to pay to fee bumper transactions. So to fix this, and these all are these are also issue. For example, like child fee doesn't count towards RBF rules and all of these. You can read it or read out for yourself. So we introduce a policy here in which, yeah, there is a policy. So these are new rules of policy, what you call. So, specifically set and version 3, like senders can signal that they want a transaction to be topologically restricted until confirmation, called truck, specifically set and version 3. So if you say any transaction with n version 3, this transaction signals for truck transactions. A node that implements this policy would apply their existing standardness and policy rules along with the following set of rules. So all the truck transactions contains all the same policies and rules as previous transactions, but these additional rules are also applied to any truck transactions. Okay. So what are those rules? We'll see. So a truck transaction signals replaceability even if it doesn't signal BIP 125 replaceability. For example, if you don't want to replace your transaction, but if your transaction is a truck transaction, it signals for a truck transaction. That transaction doesn't need to ask someone to be replaced. It automatically replaced by any any miner. If you set your n version equals to 3, then you don't need to specify to replaceability of your transaction. Your transaction will 100% replaceable. So there is no other condition. A neutral transaction confirmed unconfirmed ancestors must all be truck. For example, if you have a transaction which is truck and there is also another transaction which is there is also a transaction which is unconfirmed, but there is an ancestor transaction like the above transaction, then your created transaction, then this transaction also must be a truck transaction. Any descendant of an unconfirmed truck transaction must also be a truck transaction. For example, all the your descendant and ancestor must be a truck transaction to to process further. And this is the rule. Like uh, it doesn't happen like if you have a transaction like if you have any transaction here. Sorry, if this is the transaction and this is also a sorry. And this is also a transaction and this is also a transaction, then these both transaction also must be a truck transaction. If this is a truck transaction, then these two transaction also need to be the truck transaction, both the ancestor and the descendant. This is the descendant and this is the ancestor. And okay, so they both need to be the truck transaction. Okay, so the rule number three states an unconfirmed truck transaction cannot have more than one unconfirmed ancestor, and an unconfirmed truck transaction cannot have more than one unconfirmed descendants. CPFP carve-out is not granted to truck transactions. For example, there you can't create more than or you can't create more than one ancestor. For example, if there is one more ancestor here, this is not valid in version 3 rules. If you have one more descendant here, this is not valid. If you are signaling for version 3 transaction, this is not possible. You only need to have these three things. This is your main transaction, and these two are only possible, like one above and one below. You can't create more than one and one above one. And a truck transaction cannot have a SIGOP adjusted virtual size larger than 10,000 virtual bytes. So your truck transaction cannot have a, like, we will need to restrict the like child also. For example, if you create a child with a very huge amount of data and transaction input and outputs, you don't want to pin your transaction again. We need to prevent from transaction pinning attacks. So we are restricting our rules. That's why we aren't allowed to create more than one ancestor and descendant, because we want to prevent the transaction pinning attacks. And a truck transaction that has unconfirmed truck ancestor cannot have a SIGOP adjusted virtual size larger than 1000 virtual byte. And the sixth rule is an individual truck transaction is permitted to be below the mempool minimum relay fee rate, assuming it is considered within a package that meets the mempool fee rate requirements. So that's important. The number six is also important. So what he's trying to say? For example, if you have a truck transaction, this is the truck transaction, and this is below average fee. Like this consists of below average fee, and but this transaction is accepted only when it's consist in a package. I think you guys know what I mean by packager. I already explained what we mean by package in Bitcoin ecosystem. So a package is like an interconnected set of transactions. So this needs to be broadcast with a package. For example, another child transaction, which pays enough fees to get confirmed with both of these transactions. So with like enough pace. So okay. I think I mess with these signs here. Okay, I think you know. Okay, this pays the higher than average fees. I think this not be the average. This must be the low. Yes, yes, below low. Because if you have a below average fees, your transaction may get processed. But if you have below low fee, your transaction, there is no chance your transaction can process in a blockchain if you have below low fee. But if you have below average fee, your transaction get processed later. So that's why. So if this child transaction pays enough fee, and this contains in a transaction set or a package, then this is accepted in version 3 transactions. Even assume this transaction contains zero fee. That's acceptable by the miners. That's acceptable because this child transaction pays enough fee to process both of these transactions. So that's what the rule 6 is saying. these are the new rules introduced in the version 3 transaction relay. And I think you know what is struct transactions and all. I think that's a good overview for version 3 transactions relay for relays, policies and all. So okay, now I want to open the questions. Okay, I can't find the Bitshala channel here. Let me search. Okay. So if you have any doubts, you can answer. Otherwise, we can start with the questions. If anybody has any doubt, here to everyone, another 5 seconds for your answers. Okay, then we can proceed with the question and answer. So, what is pay to anchor and in which transaction version does it build upon? I think you know what is pay to anchor, and this is very easy. In which transaction version does it build upon? Anybody wants to answer this question?
Hello.
Yeah, hello.
Yeah. So PayToAnchor is built upon version 3 of the transaction relay
Yeah,
proposal, and
absolutely.
it basically helps to pay the fee of another transaction if even if it doesn't have enough fees.
Absolutely correct. Wonderful answer. That's the right answer. Okay. So the second question is tell any two version 3 policies that facilitates package RBF. Do you know what is where in the where these policies are written? You know? I just shown you like this question. Question number 2. Tell any two version 3 policies that facilitates package RBF. So no question, also no answer. Okay, that's all right. So now these are the policies which facilitates package RBF. You can name any two policies you want. Like any two is the valid answer. But all these six are the policies for the version 3 transactions. So what is the question? Let's go to the question number 3. Tell me the difference between anchor outputs and an ephemeral anchors. That's very, I think, a good theoretical question to answer if no, if anyone don't need to look in the codes and everything. Yeah, I think I need to review the code a little bit a review of the code of this PR. We'll do this after this Q&A session. A little quick, like in 5 minutes, I will explain you the proposed changes in this PR, and then we will bind up the PR. So let's finish the questions first, and then I will review all the code. So anybody knows the third answer? Tell me the difference between anchor outputs and ephemeral anchors. I just explained this.
Ephemeral outputs can also can be used even if the transaction has zero fee.
Yeah.
Is that correct?
Okay. Right. And in ephemeral outputs, oh sorry, in
In
anchor outputs,
uh, uh, I'm not sure. I think it is compulsory to have a certain amount of fees.
yeah, absolutely correct. The anchor outputs needs to be a very little fee to be included, but ephemeral anchors doesn't need this. And there is, I think, one more difference if you can tell. There's more. There's one more very beautiful difference between both of these two. Do you remember, or I will tell it.
I don't remember.
Okay, so the other difference is there is a condition like only two persons can utilize the anchor outputs, and in ephemeral anchors there is n number of people can utilize this feature and fee bumper transaction. I think you got it. Like there is n number of people can use ephemeral anchors, but there is a condition between anchor outputs to be the number of people limited to one.
Yes, I got it.
Okay, okay. So let's go to the fourth question. Why does the usage of ephemeral anchors rely on package relay? Like the meaning of this question is like why we use ephemeral anchors on a package relay. So a package relay is same like I explained the transaction package. It's the same concept like. So why does the usage of ephemeral anchors rely on a package relay? The same concept of package in a transaction in Bitcoin. Do you remember what is a
Because
package?
yeah, because without package relay, it is not possible to bump the.
Yeah, yeah. So the package contains so so there is a like restrictions in a package. There is not more than like n number of transactions, like one descendant and one ancestor also. So if you like if you create a transaction and a child transaction and both of these are in a package, then you can freely replicate this transaction as it's valid. Even if the parent transaction pays zero fee, it's valid because the child pays enough fees for the whole package to get mined. That's why we need package relay in ephemeral anchors. So ephemeral anchors simply needs to be in a package of transactions, needs to be sent in a package. If you send, if for example, if you send ephemeral anchors as a standalone transactions of a single transaction, this is not accepted because there isn't any child to process or to process the transaction. Anyone can like DDoS the mempool then if we don't have a child transaction with a parent transaction that pays for a enough fee. So you need a parent transaction and child transaction compulsory. Without the child transaction that pays enough fee, you can't relay. So next question: before transaction out type anchor is defined in this PR, what transaction out type would script pub key 01, and this is a hex which simply represents 473 be classified as. So do you have any idea about this question? Hint is what would solver return? Well, this is one liner question. Did you check what solver return? Any idea, or I will explain it. If you don't, that's fine. If you don't know about this, I will open the solver function here. I don't know where is solver. Yes. Are you going to answer?
Yeah,
Okay.
I have no idea what this one.
Okay. So do you know the answer? Like what solver returns?
What solve?
Yeah, as you can see in this code, the solver returns many things. For example, this, this, and this to finalize this. So the simple answer of this question is before this before this PR, if you pay someone pay to anchor script, the Bitcoin code doesn't know about to what is it, and it simply returns a transaction out type non-standard because it's not standard. You can see here is the code for this standardness because but this code introduced recently. But before this, the implementation of anchor outputs in Bitcoin, this simply returns non-standard. So the answer for this question is non-standard. Okay. So the last question, by default, a transaction must pass standardness check to be accepted to the mempool. What does is a standard transaction inspect? So is a standard transaction doesn't do anything, but it checks for the specific output scripts. For example, it's check for various output scripts. For example, P2PH, P2WPH, P2SH, P2MS, and P2TR. If any scripts belongs to this, it returns, yeah, this is the standard script in Bitcoin. Otherwise, it returns non-standard. It's simply this question. So let's quickly, I forgot to review the code of this PR here. So I will finish in 5 minutes. So whatever this PR is doing here. So what happened? Okay, okay. So this is a change in change in test. This is nothing. We are defining the anchor bytes with the name of anchor bytes instead of the hex representation of this. And this is the new proposed change. In this, we are checking a few certain things. For example, let me show in the VS browser. Oh, sorry, I don't need to open that window. Yes, I need to open this. Okay. Okay, so th this line just simply check. So this test case checks standardness of certain things. For example, if you see here, it will check like the, the script hash must be the 20 in size. But what this program is do, it stands with the size of 21 and check if the solver returns the non-standard. If it returns non-standard, that means our solver returns the exact true result. So all of these test checks something. For example, we are passing the pub key here, and we are checking with a opcode of 0 and 1, and we are checking if this is non-standard or not. By the result of solver is non-standard or not. So same here, we introduce certain things. For example, in code 204, uh, we are checking for the witness version 1 taproot. With incorrect program size, we are passing here the incorrect size of 33, and we are checking if it outputs the witness unknown or not. If the solver outputs the witness unknown, then okay, it's fine, it's correct. And this is the first change here, and the second major change here is in line number 275 here. Here. So the first check is for the witnessed version 1 taproot. For example, we are first deriving a X only pub key, like the only X part of the pub key, and then with the opcode of OP1, and then we are checking the we are like deriving a address from that pub key. If it's true, if it matches, then okay, this check proceeds. And we are checking if this address is of type version 1 taproot or not by comparing both of these results, the results here and this S and this original pub key. We are checking if it outputs the same, that means yeah, okay, the program is correct. Same for the anchor outputs. We are inserting the anchor bytes in S, and then we can check. We are deriving the address of S, and for this address, we are checking if this address like signals for pay to anchor. If it signals for, then the test must be true. That's all this function is doing. Same here. This witness version one taproot. It's checking for the taproot by driving the x part of the public key, and then pushing some codes like op1, and we are first converting this to the bytes form, and then pushing this result in expected, and then check the result with passing the GetScriptForDestination and witness version 1 taproot, and we are passing here the x only pub key, and we are checking whether the result is equals to the expected, which must be equal. If it's true and running, then this must satisfy the condition. And same for a pay to anchor. Uh, we are op1 opcode and then anchor bytes, and then we are checking like if it's pay to anchor scripts, if it's standard or not. If it's standard, it must return with the result same as expected. What are expected means like 0 1 opcode, and with the anchor bytes, this get script for destination must return the same thing as expected, like this expected 0 1 opcode and anchor bytes. If it's true, then our test is true. That's all about the test. I think that's all about this PR. Thank you for joining, everyone. That's all.